Today is March 14th, indeed, and we're going to talk about Solution 146. And some of the information I want to share right here at the beginning is just a brief introduction to my thinking process of how I came up with the examples that I'm going to talk about today and how I wanted to present it. There's not a whole lot of time here to do this, so we'll try and be as brief as we can, but give you sufficient detail and hopefully stimulate interest to go ahead with exploring this, because I think there's a lot more to learn about our aeroelastic analysis that we can gain from Solution 146 than just doing, say, a Solution 145 flutter analysis. And I'm going to tie Solution 146 back to 145 as we go through the description of each of the slides that I'll present. It's interesting to note that one of the references that or the only reference I'm going to mention in this paper is one that appeared in 1955, which is about the same time I was in the high school freshman algebra class. And my algebra teacher gave us a piece of advice that has stuck with me over that period of time. And that is that with mathematics, you always start from something known. Otherwise, you don't know what you have when you get to the end. So with that in mind, I thought about how to present examples that would illustrate this, that have credibility and be able to validate the process that we go through here. And it stems from that old example that's in the Aeroelastic Handbook or the Aeroelastic Analysis User's Guide. Either one of them have this model described in it. That handbook is the older document. The version 68 Aeroelastic Analysis User's Guide is the current document. Doesn't mean that there's anything wrong with it. It's just that it doesn't have any of the new data or stuff that's been put into the program since version 68. So with that sort of brief overview of what my thinking process, we'd like to go through what the table of contents has here and keep in mind where we're going. And we're just going to get a brief introduction and then talk about the theory behind the Solution 146 processing, because it has all four of these functionalities. You can do frequency response analysis, random analysis, transient response analysis. And the transient response analysis is done through the Fourier series integrals that have been built into the program. And realize that this technology has been around since the late 1970s, and you could have done these problems at that point in time. Maybe not quite as easily or as quickly, but certainly you could have done these same input files in pretty much the same way. And then we're going to talk briefly and just highlight the input specific to Solution 146 and realize that there's a lot in common between Solution 146 and 145 that we won't cover in any significant detail because we just are too short on time. What I want to get to is this 15-degree swept wing model examples and talk about the flutter results, and then go into the transient response, frequency response, and random gust analysis.